Okay, so today we're going to start talking about congruent triangles. We've got some definitions we need to talk about. The first definition is postulate. A postulate is a statement that has been accepted as true. So it hasn't been proven. It just comes up over and over and over in math. We can't exactly prove why it's true, but we know that it's true based on induction, meaning that it just keeps happening over and over. Now, a theorem is a statement that has been proven true, and you've probably heard of the Pythagorean theorem. It's something that has been proven. Now we have CPCTC. It's an acronym. It stands for corresponding, see where the C comes from, parts of congruent triangles are congruent. CPCTC. And what that means is that if you have two triangles that are congruent, then you can say that the angles and the sides that correspond to each other are also congruent. So based on one single statement saying you've got two triangles congruent, you know that three angles and three sides are also congruent. Now we have a triangle congruency statement. Right below it, I have two triangles that are marked congruent. I've got all the sides marked and all the angles marked that are congruent. Now, when you write your triangle congruent statement, we've got the two triangle symbols. Remember those from before? We've got our congruent symbol. Now, it doesn't matter how you write the first triangle. So I just did A, B, C, just to go in alphabetical order. Now, whenever you write the second triangle, you need to make sure that the correct angles match up. So, if you look at A, it's got one little rainbow mark, and so does D. So that's why when I wrote A first, I wrote D first. Now B has three little marks, and so does E. That's why if you have B second, you got to have E second. And then C comes next, and then that one also, F also has two marks. That's why F comes last. Now the order is important because it tells you which angles and which sides are congruent. So here's our first example. It says, given the following triangle congruent statement, name all congruent sides and angles. So we're going to use CPCTC because we know that these triangles are congruent to break it down to individual sides and angles. Let's do the angles first. The angles are normally pretty easy. Now, angle F is going to be congruent to, and if you look, F is written first and C is written first, so angle F is going to be congruent to angle C. Angle O is written second, so in the other triangle, angle A is written second, so angle O is congruent to angle A. And then lastly, angle X is congruent to angle T. So there's our angles. Now our sides, remember when we name sides, we have segments, so we've got to have two letters. Now this is pretty easy. We're going to say side FO first. So segment FO, and don't forget, we do a line above it. It's congruent to, now FO is the first and second letter, and so CA is the first and second letter in the other one. So segment FO is congruent to segment CA. Then, let's do another combination. OX would be congruent to, and if you look what matches up where OX is, we have AT. And then the last combination of letters is we need to put together F and X and C and T. So, if I say FX, that's the first and the last, then CT would be the first and the last for the cat. So there's our corresponding angles and sides, and by CPCTC, because we have this triangle congruent statement, we can say that these things are congruent. Now moving on to B. I would like for you to pause the video and see if you can get the corresponding sides and angles for example B. Okay, now that you've tried it for yourself, here are the solutions. Now, your angles have got to be matched up exactly like mine, but as far as your sides, if you have it written backwards like ML and then QP, that's fine as well. So you can transpose the letters for the sides as long as you have those two specific letters grouped together. So now we've got a bunch of postulates and theorems that are going to say that triangles are congruent. We've got 5 of them. Now the first one is a postulate, so it hasn't been proven true. It's called the side-side-side postulate, and it's abbreviated SSS. So it says if all 3 sides of one triangle are congruent to all 3 sides of another triangle, then the triangles are congruent. So I've got it also in picture form. So it says if, and I've got 2 triangles here, and all of the sides are marked congruent. So AB is congruent to NL, and so on. So match up the tick marks. So if you got this side and this side congruent, BC and NM congruent, and also AC and LM congruent, then we can say the 2 triangles are congruent. So we have our congruency statement. Now remember, you got to be really specific about the order. If you go from A to B to C, so we went from, let's see, we want to go, what matches up with A? A is between the 1 tick mark and the 3 tick mark. So if we look at the other one, the one that's between 1 and 3 is L. So we're going to start with L. Then we go to N and to M. So there's our triangle congruent statement based on this picture. Now here's another one. A postulate is called the side-angle-side postulate. It's abbreviated SAS. It says that if 2 sides and the angle between the 2 sides of one triangle is congruent to 2 sides and the angle between the 2 sides of another triangle, then the 2 triangles are congruent. Now, it's also written in the letters. We're talking about a specific angle between 2 sides. Now, literally that A is between those 2 S's. So let's look at our picture. We've got DE, which is marked with 1 tick mark. We've got MN, which is marked with 1 tick mark. We've got those 2 sides congruent. Then we also have EF and NL congruent. Now, specifically for this one, we need the angle between them to be congruent. So that, since that angle between them is congruent, we can say that these 2 triangles are congruent by side, angle, side. So here's our triangle congruency statement. Make sure you put them in the correct order. Now the next one is a postulate. It's called the angle-side-angle postulate. Now, just like before, the A's and the S's go in specific orders. So it says if 2 angles and the side between the 2 angles is congruent to 2 angles and the side between the 2 angles of another triangle, then the 2 triangles are congruent. So, literally between, that's the important part. So we have the side that's between the 2 angles. So here's a picture. I've got 2 triangles marked congruent. I'm got a 1 mark here, a 1 mark there. And then I've got 2 here and 2 here. And literally the side that's between those 2 angles is also congruent. So because we have this specific situation, we have angle, side, angle congruent. So here's our triangle congruency statement. Alright, the next one is actually a theorem. So this one has been proven. Is the angle-angle-side congruence, abbreviated AAS. Now make sure that you notice the difference between this one and the one before. We have 2 A's and an S, just like here, 2 A's and an S, but the difference between here is the order. In angle, side, angle, the side has to be between the 2 angles, but in angle, angle, side, the side is not between the 2 angles. So it says, if 2 angles and a side not between the 2 angles is congruent to 2 angles and a side not between the 2 angles of another triangle, then the 2 triangles are congruent. So we've got 2 angles congruent. We've got P congruent to R. Notice they have the same mark. M is congruent to L. They also have 2 marks together. But notice this side is not between those 2 angles. So that's why this one is angle, angle, side, and not angle, side, angle. And here's our triangle congruent statement. Now the last one is very specific. It's called the hypotenuse leg congruence. This one is a postulate. And it's for right triangles only. Right triangles only. It says, if the hypotenuse, remember the hypotenuse is the longest side of the triangle. It's across from the right angle. If the hypotenuse and a leg is just another side that's not the hypotenuse, of one triangle is congruent to the hypotenuse and a leg of another right triangle, then the two triangles are congruent. I forgot an R here. So here's a picture. Now, remember how you know a triangle is right is if it's got this right angle mark, that little box in the corner. So the hypotenuse, remember, is the side across from the right angle. See that? We've got our two hypotenuse marked congruent, and a leg is just any other side. So because we have the hypotenuse and one of the legs, we can say that the two triangles are congruent. And here's the triangle congruent statement. Now we're going to apply these 5 postulates and theorems and look at some pictures to determine if things are congruent. But there's a few things you've got to remember from before. So when you're trying to determine if two triangles are congruent, do not forget what you know about other stuff. You know that vertical angles are congruent. Remember, vertical angles are across from each other at an intersection. And if a side or an angle is shared, it is congruent to itself. And also remember that all right angles are congruent to all other right angles. If an angle is 90, it's 90, it's 90. And that means that they are congruent. So let's get into our last example. It says, determine if the two triangles are congruent. If so, by which postulate or theorem? And I'm going to come over to the side and I'm going to write all of them. So we had side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. Remember, hypotenuse leg was right triangles only. That's not to say that you can't use the other 4 with right triangles, because you definitely can. And I think one of these examples you actually do. So let's look at A. So right now we've only got 2 things marked congruent, and we need 3 things marked congruent to prove that 2 triangles are congruent. Now what we have here is we have a set of vertical angles. This angle is congruent to this angle because they're vertical. Now we have 3 things, so let's figure out if it fits one of our postulates or theorems. So we have an angle between 2 congruent sides. So an angle between 2 congruent sides is the side angle side postulate. So those triangles are congruent by side angle side. So let's look at B. On B, again, we only have 2 things marked congruent. We need 3 things, except for when we're dealing with right triangles. Actually, that's still a 3rd thing because you need the right angle. So if you take a look at it, these 2 triangles share this side, FO. If it's shared, it's congruent. So let's take a look. We've got 2 angles and a side. So 2 angles and a side. So it's either going to be one of these 2. But we need to determine, is that side between those 2 angles? Now, that side is not between those 2 angles. If it was, we'd be talking about this side. But we're not. So we've got 2 angles congruent. And we also got a side that's not between those 2 angles congruent. So we can say that this one is congruent by angle, angle, side. So let's look at C. C, we've got 2 things marked congruent. So let's take a look at our picture and see if we can mark anything else congruent. These 2 triangles share a side. They share side PT. So I'm going to mark it, but I'm going to use 3 tick marks because we've already used 1 and 2 in other parts of this problem. So if you take a look, we've got 3 sides congruent to other 3 sides of another triangle. So these 2 triangles are congruent by side, side, side. Let's take a look at D. Now, these appear, they kind of look like right triangles, but we can't say that they're right triangles. We can't just make that up. So let's take a look here. We have an angle and 2 sides congruent. So let's look at our possibilities. An angle and 2 sides. We've only got one thing that's got an angle and 2 sides. That's side, angle, side. But remember, with side, angle, side, we had to be really specific, and that angle had to be between those 2 sides. But if you take a look, this angle is not between these 2 sides. If it was side, angle, side, we'd be talking about this angle being congruent. So these 2 triangles They might be congruent, but we cannot say that they're congruent based on what we're given. So we're going to write not congruent. So let's look at E. We have something shared. So I'm going to mark this side congruent. But also, if you take a look, we have a right angle here. Uh-oh. Let's see if we can use hypotenuse leg. So the hypotenuse is across from the right angle. Now, if this angle right here is right, also this angle is right. And there's our hypotenuse. So our hypotenuse is congruent. And since this leg is shared, it is also congruent. So these two triangles are congruent by hypotenuse leg. And let's look at F. We have two angles and one side congruent. Now, if we wanted to use two angles and one side, let's go back. Two angles and one side, we're talking about either one of these two. Either that side is between those two angles or it's not. Now this side is between these two angles, so we can say that these two triangles are congruent by angle, side, angle.